So if we have chosen that carbon as a carbon atom for comparing the mass of other one, so we have chosen. But as a whole carbon atom, we have not taken. It's one part. If we did the 12 part of this whole carbon atom, then it's 1/12 part of carbon 12 atom of carbon 12. Why I'm writing carbon 12? Because carbon are two types. One is carbon 12 and another one is carbon 14, which means one carbon atom is one which is going to have 12 mass, another carbon atom is one which is going to have 14 mass. So we have just chosen this one, carbon 12. So it is simply we can say that 1/12 part of carbon 12 atom is taken as standard comparing quantity. Standard comparing quantity for the mass of other atoms. And we called it 1 AMU. What we called it? 1 AMU. So please note it down, this one in a copy, that 1/12 part of carbon 12 atom is taken as a standard comparing quantity for the mass of other atoms. Neha, are you there in the class?
Yes, sir.
Please turn on your camera.
Okay.
You are on the focus mode. Nobody can see, only our team and I can see. Okay, and the video will be safe.
Okay.
So, sir, the 1/12th part of the carbon 12 is called 1 ammo.
1 AMU, 1 atomic mass unit.
Okay.
We called it 1 AMU, 1 atomic mass unit. Okay. When you did, please let me know. Yeah.
Yes, sir.
So we are just talking about this one, that not as a whole, but we are saying that the atomic mass unit. So what is atomic mass unit? So atomic mass unit, it can be defined as the quantity of mass equal to 1/12 the mass of carbon 12 atom. Okay. So what is atomic mass unit? What is 1 AMU? So 1 AMU is the atomic mass unit is defined as the quantity of mass of 1/12 mass of carbon 12 atom. Okay. So here, if we are just calculating the mass and we just start comparing it, so we find that one hydrogen atom is equals to, okay, one hydrogen atom is equals to 1 times the 1/12 the mass of carbon 12 atom. Okay, of carbon 12 atom. And similarly, we have noticed that the nitrogen, one nitrogen atom were having the 14 times this 1/12 mass of carbon 12 Similarly, one magnesium atoms were having the mass of 24 times this value, mass of carbon 12 atoms. So every time I'm just writing this one, that 1/12 the mass of carbon 12 atom, 1/12 the mass of carbon atom. So it was given in standard unit that 1/12 mass of carbon 12 atom is is considered as 1 EMU. Okay. So if it is hydrogen, so the mass of one hydrogen atom is 1 AMU. The mass of 40, mass of one nitrogen atom is 14, and this value is 1 AMU. So you can write it 14 AMU, 14 atomic mass unit. Okay, and this one is 24 AMU. Okay, understood? So again and again, don't write it like this way. Okay, we can write it 14 AMU. Okay, got it? Understood?
Yes, sir.
Next one is when we keep on, if I'm talking about this one, that if we are having uh, when we have further, because carbon atoms, and we have chosen as 1/12 the mass of carbon atom, carbon 12 atom. Okay, so it is not in the grams, it is in AU. So due to spectroscopy method, when we have developed machines and developed equipment, then we have spectroscopy. So spectroscopy methods help us to find out the accurate mass of the actual carbon atoms in grams. So we find that the one carbon atoms mass in grams is found to be how much? That is 1.99 into 10 raised to the power minus 23 kg. Okay, sorry, minus 23 grams. So we find that the mass of one carbon atoms was found to be 1.99 into 10 power minus 23 grams. But this is not the, we are just taking the mass of this carbon atom in grams. That is 1.99 times power minus 23 grams. So actually, we have not chosen the whole atom. We have chosen 1/12 part. 1/12 of mass of carbon 12 atom will be actually equals to this mass divided by 12. So when we divide it by 12, you will find that it is equals to 1.66 into 10 raised to the power minus 24 grams. Or it will be equals to 1.67 66 1.66 into 10 raised to the power minus 27 kg. Got it?
Sir,
Yes.
like I'm not clear about it.
So I'm saying it, Rima, that we, by the methods of spectroscopy, a special technique to find out the mass of small things like atoms. So we are able to find out the whole mass of this one carbon atom. Okay, that we find that this mass of one carbon atom in grams is 1.99 10 power minus 23 grams. This is very small in size. That is 0. Okay, 192. Okay, so this will be equals to like 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 3, 3, 9. Okay, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, and that will be this. This is very small in size in grams. So this is one atom has going to have mass this much value in grams. So we write it like 1.99 into 10 raised to the power 23 in grams. Okay, so this is very small unit. So we are able to calculate. So, but we have not chosen this as a whole. We have chosen how much mass? We have chosen 1/12 mass of it. So we can calculate the mass of one EMU. So what is the mass of one EMU in grams? One EMU, which is equals to 1/12 part of carbon 12 atom. So we have chosen this whole carbon 12 atom as mass Mass of one carbon atom in grams is 1.99 10 to the power minus 23. So what is the mass of its 1/12 part? 1.99 into 10 to the power minus 23. When you divide it into 12 parts, so one part is going to have 1 eV. So when you divide it, you will get this value. This value. That is 1.66 into 10 to the power minus 24. So let you write it from here. Okay. Note it down. That atomic mass unit was defined as 1/12 mass of carbon 12 atom, and 1 AMU is equals to 1/12 mass of carbon 12 atom, and it has a value of 1.66 into 10 to the power minus 27 kg. If you convert it into grams, then you can write it 1.66 into 10 to the power minus 24. So please note this definition. What is one atomic mass unit? Note this definition, everyone.
Sir, I'm not still clear about it, sir.
Yes, Rima, we will give you the homework to read this one. First you will read, then I will explain you, okay? So first read this one. You will get this one surely. I am going to help you. Just maintain for the class. More, give me 10 to 15 minutes, and then you will be cleared. Okay. Some topics are not understandable at the time of when we are teaching. The concept get clear after 15 to 30 minutes. When we keep on teaching the same statement. Okay.
Sir, from where should I start writing?
Atomic mass unit.
Okay.
Are you writing? Are you writing, Alvina?
Yes, sir.
So, can you clear me what is atomic mass?
Atomic mass is the mass of an atom. For
Okay.
example, what is the mass of one nitrogen atom? Nitrogen atom is very, very small in size, so it should have very, very small mass. Okay. So actually, we cannot compare first when we are just trying to calculate the mass of an atom. We cannot compare the mass in grams because grams is very, very big unit. For example, it is just if you are having if you can you measure the mass if you have if I ask you to measure the mass of one ant you know ant cheating. Okay, so that is very small in size, and I'm giving you two elephant to compare it. Okay, that you have one elephant and one ant. You have to compare it. You don't have the smaller weight, so can you compare? Can you keep one ant on the one side, another another on the other side at the elephant? No. So you need a smaller weights that is approximately the similar size of that ant, so that you can compare it. Okay, so we just compare it by choosing carbon atom. We just start choosing that how much this atom is heavier as comparison to this carbon atom. Okay, so we have made an atom as a weight. Okay, as a weight for comparing. Like we have length, Okay, for example, if you need to measure the distance from here to here, you have meter scale, 1 meter, then 2 meter, okay, then 3 meter. So we will measure it comparing because you have a length 1 meter, that this distance is 1 meter. You just keep on multiplying and you will measure the distance between one point to another point. And similar is okay. Uh, similarly, if you are just going to measure the weight of an atom, so if you are just hydrogen atoms here, so you cannot consider this as a whole. You cannot consider the gram. Gram is very big unit. So we just compare. We just compare it that how much this hydrogen atoms is having with this carbon atom, and not as a whole carbon atom. We have just chosen as a carbon, and it's 1/12 part. 1/12 part, not as a whole carbon atom. We just have a carbon atom. We just break it into 12 pieces. One piece, like we have pizza. Okay, the whole pizza we have not chosen for comparing. We have chosen it's what if we have a pizza and we cut it into 12 pieces, then one piece of that pizza is considered to be a standard weight. So we have we just keep one pizza slice, 1/12 part of that pizza slice means we just keep we just divide it into 12 parts and we just keep it. This is 1/12 part. So we just keep this slice on the one and just keep the hydrogen atom, the other atom, that how much times we need to keep it. Okay. For example, for example, if we need to measure the weight of carbon for magnesium atom, so we will, for magnesium atom we have such 24 pieces, such 24 pieces, 24 such pieces of carbon 12 atom, and that will be equals to one magnesium atom mass. So we say that magnesium atom is 24 times 24 times heavier, heavier, heavier than the mass of this one mass. This, the mass of this one is 1/12. This is, what is this? This is 1/12 part of carbon 12 atom. Okay, 1/12 part of carbon 12 atom. So we just start comparing it. Understood? We find that only one slice is equals to mass of one hydrogen atom. We find in our experiment that we have only one slice, and this slice is going to have the mass of one hydrogen atom. So we'll say that one hydrogen atom is equals to one slice. Okay. Okay. We find that such 14 slice, such 14 slice, 14 how many? 14 slice is equals to the mass of one nitrogen atom. Okay. Such 14 slice is equal to the mass of one nitrogen atom. Got it? Gavin, are you getting my point?
Yes, sir.
Yes, sir.
Are you sure?
Yes, sir.
So we'll say that here that if we have 14 such slices, then it will be equals to the mass of one nitrogen atoms. In case of oxygen, we need such 16 slices, 16 slices. And that is equals to the mass of one oxygen atom, one oxygen atoms. We need such 32 slices. 32 slices equals to the mass of one sulfur atom. Understood? Okay, so this is the way that how and what is the name given to this slice of carbon 12 atom? The name of this slice is 1 EMU. Got it? So if we have one hydrogen atom equals to one slice, it means the mass of one hydrogen atom is 1 AMU. If we have one nitrogen atom is equals to 14 such slice, so the mass of one nitrogen atom is equals to 14 AMU. If we have one oxygen atom is equals to 16 such slice, the mass of oxygen atoms is 16 AMU. So we named this slice as one atomic mass unit. Okay.
Okay.
If we have this sulfur atoms and we are going to have this 32 sulfur atom is equals to we write 32 AMU. If 32 slides are being required, such slides are being required for making for the equivalent mass of sulfur. So we'll say that 32 is the mass of sulfur. Okay, understood now? Got it?
Yes. Yeah. Yes, sir.
So here are the mass of some important atoms. So please note it down.
Okay, sir.
Note these mass of some important one that I'm going to write some other also. Done?
Just a minute.
So were we supposed to write the atomic mass? The notes.
Yes, in the notes you have to write down, and you have to memorize this also. You need to.
Like before atomic mass unit. The notes.
Yes, yeah, you can write it here only.
I didn't write it down.
You have already written it down.
No, I
Somewhere.
haven't.
So note it down now. This is the atomic mass of the elements. Make the table. Now,
The
go on.
definition.
I'm done writing.
Still writing. So done. Should I move further? Can be noted.
Done, sir.
Okay. So there are
Yes, sir.
some other elements also. Sulfur is being written here. Nitrogen, then 12. Okay. Then 14, 16, 23, 24, 32, 40. Iron is going to have 56 noted down. Iron. Iron is going to have 56 mass. Okay. Iron is Fe. The symbol is Fe. Okay. This is name. This is mass and this is symbol. Potassium. Potassium is K. Mass is 39. Okay. So we have written sodium. Phosphorus. That given symbol is P.
So what you have written at first?
Iron. IRON. Iron.
No, above that I'm not able to.
Name, mass, and symbol.
Okay.
Phosphorus 31. Done. Of copper is 64. Done. Noted. Noted. Everyone.
Yes, sir.
Okay. So if I ask you to calculate the molecular mass of the following formula that I'm going to write here, that is aluminium sulfate, Al2SO4. So how will you be able to calculate the mass of this aluminium sulfate? So here we have two aluminium atoms and three sulfate molecule. So you know that the mass of one aluminium is 27. So you have 2 such two. You have to multiply 2. Okay, 2 times. Because there are two aluminium atoms. Going to 27. Got it? Plus mass of sulfur atom is 32. One sulfur atom is 32. So we are just calculating the mass of one SO4. Okay. And we have 16 plus 16 plus 16 plus 16. Four such oxygen atoms. So 16 for each. This is the mass of one SO4. And how many SO4 we have? We have 3. So multiply this 2, add this one, and then multiply this 3, and then add 2. Calculate the mass. Done this one? So what is 27 to the 54 plus 32 plus 16, 16, 16, you will get 64 plus 32. You get 96. So 96 3 is a. So 96 into 3, what you will get? 28. Got it? Add these two. 54 plus 288. What you will get? Tell me. 8 plus 4, 12, 1 carry. Then 5, 8, 8, 5, 30, 40, 342. The mass of Al2 is 4 whole price is 342. Now you understood how to calculate the mass? Alvina, you understood? Nabila, Rima, Galvin,
Yes, sir.
Sir,
you
I didn't
understand?
understand.
Sir, done, sir.
You understood? Let me explain you one more time. Al2SO4 whole thrice. Okay. Got it? So we're going to know that how we can calculate the mass of this. So how can we calculate? So if we are having aluminium, there are the two aluminium atoms. Alvina, look at this.
Yeah.
They are the two aluminium atoms. Okay. And these two aluminium atoms, each is going to have 27, 27 mass. So this is going to have 27. This is also going to have 27. Okay. So I'm just going to write here. You can write it Al2SO4 whole thrice. Okay. This 3 is multiplying with this sulfur and this oxygen also. Okay. So we have aluminium, and how many aluminium atoms? 2 aluminium atoms. Okay. We have sulfur atoms. How many sulfur atoms we have? How many sulfur atoms? Galvin, tell me. How many sulfur atoms we have?
3.
Galvin,
Is
tell
it
me.
3?
3. Yes, it is 3. You have to multiply it by 3. So it is 3 sulfur atoms. Okay. And how
Okay.
many oxygen atoms we have?
3.
Not 3. They are already SO4 and then 3. 3 for the 12. Total how many oxygen atoms are there? 12.
12.
Because one atom of SO4 is going to have 4 oxygen atoms. And we have such 3. So this 3 is the 3 that is present here is not only multiplying with this sulfur, it is multiplying with this one and this one, but not multiplying with this one. It is not multiplying with this one. Understood?
Yes, sir.
So we're going to have 12. So what is the mass of this one? That will be 2 into 27 plus the mass of one sulfur atom is 632. So 2 into 32 plus the mass of one oxygen atom is 16. So 16 into 12. Add all these. 27 to the 50. 4. 32 3 the 96. Okay, plus 16 into 12, what you will get? 204. Add all these three, you will get the answer. 4, 10, 4, 1 carry, then 10, and
Sir, it's 192.
6, 84, 4
12
carry,
into
12, and 8. Yes, balance. Oh, yes, it is 192. Wait a minute. It is, I just multiplied with 17. Thinking this is 179. Okay. This is 16 into 12. You will get 16, 7, 12, 6, 72, 70, 12 on that one, and 7, 190. This is 199. So when you add it, you will get the answer as 6 to 12. Okay, 6, 8, 8, 6, 12, 1 carry, then 10, 10, and 5, 1. Okay, so you will get the answer like this. Got it? Understood?
Yes, sir.
When you add it, you will get the answer.
Sir,
Yes, Emma. You didn't understood?
still it's confusing, sir.
It is very simple, Rima. This you left the class, that's why you don't understood. Let me explain you one more time. So, other students who understood this topic, please calculate the mass of potassium nitrate, KNO3. Calculate the mass of potassium nitrate. Rima, you look at this. This is aluminium
Okay.
sulfate. Aluminium is going to have mass 27 that you have written in your copy also. And this is
Yeah.
two written here. It means this is 2 aluminium atoms. Okay, this is 2 aluminium atoms. So mass of one aluminium atom is 27. So you multiply it by 2, you will get what you will get. 27 to the 54. Because there are 2 aluminium atoms. And one aluminium is 27. The other aluminium is also 27. To 27 plus 27 will give you 54. Okay.
Okay.
And how many sulfur atoms are there? Sulfur is this 3. This is SO4 and whole bracket 3. This means this 3 is going to multiply with this sulfur also. So this is 3 sulfur atoms. Total 3 sulfur atoms. So 3 into the mass of one sulfur atom is 32. So 3 to the 6, it is 96 the mass of this one. And the next one is oxygen atoms. How many oxygen atoms are there? You will check that the 4 oxygen atom is present in single SO4. If it is single SO4, then it is 4 oxygen atoms. But it is 3 written here. This 3 is going to multiply with this one, 4. So you will going to have 12 such oxygen atoms. 4 3s are 12. Okay. So one oxygen atom is going to have mass 16 to 16 into 12. What you will get?
16 to 12.
You will get 192. 16 into 12, you will get 192. So add all this 54 plus 96 plus 192. So you will get, okay, plus 192. So when you will get here, this one, you will get 2, 4, 6, 10, 12, 1 carry. Okay, then 10. Okay, 1 and 9, 10, 10 and 5, 15, 15 and 9, 24. You carry, and then 342 you get the answer. Okay. Have you calculated the mass of potassium nitrate? Kelvin? Kelvin, are you there in the class?
Yes, sir.
Have you calculated the mass of potassium nitrate?
No, sir. Still finding.
So again, in potassium nitrate, KNO3. One atom
Sir,
is
I got the
potassium.
answer as 5.
What is your answer?
5.
5. Only 5.
I got 101.
How 5, Alvina? You got 101. Okay, so we have oxygen atoms is 3. We have 3 kinds of atom: potassium, nitrogen, and oxygen. And how many oxygen atoms are there? 3 oxygen atoms. So you write 3. This is only one potassium atoms and 1 nitrogen atoms we have. So write 1 into the mass of one potassium atom is 39. Then 1 into the mass of one nitrogen atom is 14, and one oxygen atom is three oxygen atoms. So mass is 3 into 16. So add all these. 39 plus 39 plus 14 plus 16 3 are 48. So when you add all these, 9 and 9 and 4, 13. Okay. Now you understood, Almina? Okay. Okay.
Yes, sir.
This is the first, and that's okay. So next is. So what is the mass of this one? When you add all this, 9 and 4, 12 and 9 is 1. Okay, that is going to have 2 as a carry. Okay, then 3 and 2, 5, 5 and 1, 6, 6 and 4, 10. So how much you are getting? Galvin, how much mass you are getting? You have not yet. Nabila, how much mass you get?
101.
1, 0. Yes, it is correct. So when you add carry S2, you get 2, 3, 5 and 5, 10. The total mass is 1, 0. Understood?
Yes, sir.
So let's I'm going to give you the some chart, a table chart of this one that you have to note down in your copy in the okay. So this is a chart. Let me show you where it is. Okay. Now we're going to write how to write the molecular formula of the compound first, and then we'll write to okay. Atomic mass we have discussed. So you have to learn this table. Okay, you have to memorize this table. For example, this is potassium. You have to make this table in your notebook also. Sodium is Na. It is going to have +1 valency. Na is going to have +1 valency. Okay, +1. If it is only plus charge, it will +1. Potassium is going to have +1. Silver is going to have +1. Copper is going to have +1. Magnesium is going to have +2. Calcium is going to have +2. Zinc is going to have +2. Iron is going to have +2. Okay. So aluminium is going to have +3. Iron, if it is written 3 here, that means it is going to have +3. If it is iron is going to written like this 2 in front of it, it means valence is 2. Next is hydrogen is +1. If it is hydrogen, it is +1. If it is hydride, it is -1. Chloride, bromide, iodide, oxide is -2. Sulfide is S-2. So you have to write, memorize this one. Okay, like ammonium is going to have NH4. The formula is NH4, and it is going to have togetherly the valency of. Let me explain you some important one. For example, if we are going to have ammonium ions, so it is NH4. It is a formula, but its valency is 1. Okay, like carbonate ion, so its valence it is CO3. Its formula is CO3, but its valence is -2. Sulfate, that is SO4. Its valency is 4, but its valency is -2. But its formula is SO4. Its valence is -2. For example, if you are going to write the formula of sodium sulfate. So sodium is going to have +1 valency. You can check in the table. It is +1. And sulfate is SO4 group, and its valency is -2. It is written like this. So just write the valency here, this one here, and this one here. Don't write plus and minus here. And then cross multiply these two. You will get Na. This 2 will go here, Na2SO4. as the formula. Okay, got it? This I'm going to give you a hint of this one. In the next class, we're going to discuss in detail. So calculate the molecular mass of sodium sulfate. Calculate the molecular mass of sodium sulfate with the help of table that you have been given. Calculate it. Done. Done, Alvina? Kelvin, what's the mass of Na2SO4?
So I'm doing so.
Okay.
So, how do we get when you're doing the? Can you repeat the
What?
step? Like
Step. We have sodium atoms. How many? Na is sodium. So what is the mass of sodium? 23. So first write the number of atoms, the kinds of atoms. Na, sulfur, and oxygen. Okay, we have Na2SO4. Okay. So how many sodium atoms we have? 2. How many sulfur atoms we have? Only 1. How many oxygen atoms we have? 4. Got it? Now multiply each of them with their molecular masses. Sodium is going to have 23 mass. Sulfur is going to have 16 mass, 32 mass. 32 mass. And oxygen atom is going to have 16 mass. So it is the number of atoms and it is the molecular mass of each atom. Okay, that you have written in the table. And add all these. 23 into 2, you get 46. 32. And then 64. Add all these.
$142.
Sir, 142.
So 142.
Sir, it's 142.
What is the formula for calcium Ca3PO4 whole twice? This is calcium phosphate. How can we write this formula of calcium phosphate? We'll discuss it. But I'm going to help you. Right? Calcium is going to have +2 valency and phosphate is PO4. Okay. So with the help of this chart, you can check it here that phosphate is written here. Phosphate is written here and it is PO4. Okay. And its valency is written here. This small 3 is its valency. Galvin, you just look at the screen. Okay. Don't look at here and concentrate on the screen. This is important. Okay. This is PO4 and PO4 is, hey Galvin, look at the screen. PO4 is going to have valency -3. Okay. And what's the valency of calcium? So calcium is going to have +2. Okay. Got it? So phosphate is PO4. You understood?
Yeah.
So you can write it. This is calcium. This is going to have 2 valency. We will write here +2 and PO4 is going to have 3. Got it? You cross multiply these two. Okay, you cross multiply these two, you will get Ca3 This 3 will goes here and this 2 will comes in bracket because it is more than one items. So we have to use the bracket for it. Okay. Alina, you understood?
Yes, sir.
For example, if it is we are going to write calcium chloride, the calcium is going to have 2 valency. You can check it. And chloride is going to have -1. So don't write minus and plus here in between. You can check in the table also. Okay. Chloride, where is chloride? Chloride is this one. Chloride is -1. Minus means if it is only minus sign, it means it is going to have -1 valency. Okay. Nabila, look at this. So if we are going to have this, calcium is going to have +2 and chloride is going to have 1. So we just cross multiply these two. We will have Cl2. We don't write whole because Cl is only a single atom, chlorine. Okay, so we'll write Cl2. Okay. But if we are going to have PO4, P is phosphorus and O is oxygen. So we have to use bracket for it. Okay, so we are going to have, if we are going to write the formula of calcium phosphate, so calcium is 2 and phosphate PO4 is valency is 3. So we cross multiply it, we get Ca, this 3 will goes here, Ca3, PO4, this is PO4 and whole bracket will be, now calculate the mass of calcium phosphate. Calculate the mass of calcium phosphate. Molecular mass of calcium phosphate.
Sir, is it 4100?
4,000? No, beta. It is, you are doing some mistake. I think you are just multiplying all. No, you have to, I know where you have completed the mistake. I think you have done like this. How many calcium atoms are there? First, you will write calcium, then phosphorus, and then oxygen. Okay, the total number of atoms are this. Okay, how many calcium atoms are there? Tell me. 3.
3. Yes.
How many phosphorus atoms are there?
1.
Not 1. This 2 is in whole bracket, and this is also going to multiply with this one.
Okay.
Okay, so how many phosphorus atoms are there? Tell me, Rima. How many phosphorus atoms are there? How many
It will
phosphorus
be
atoms? 2.
31 into 2.
Yes, it will be 2. Now the number of atoms we are just calculating. How many oxygen atoms are there? Galvin, you need to answer me that how many oxygen atoms are there in this calcium phosphate. Galvin, are you there in the class? Please unmute your mic. How many oxygen atoms are there in calcium phosphate?
5.
I'm continuously watching you that you are not concentrating on the class. You are looking here and there. Are you fine?
Yes, sir.
Sure.
Yes, sir.
So I'm asking that this is 3 written here in front of calcium, so it means this is 3 calcium atoms. If it is phosphorus, So we are just multiplying this phosphorus by 2 because this PO4 is surrounded with 2 whole twice. So it is going to multiply with this one and this one. So there are 2 phosphorus atoms. And how many oxygen atoms are there? 8. Because O4 is there. PO4. PO4. Okay. In whole bracket of this one. So if we are multiplying with this one, we get 2 phosphorus. When it is going to multiply with this one, the 4 is already present in 1. So it will be total 8. Okay. Alvina, understood?
Yes,
Yes,
sir.
sir.
Now you have to multiply it with their masses. Calcium is going to have mass 40. So write it as 40. Phosphorus is going to have mass 31. Write 31. And the mass of oxygen atom is
16.
16. So add all these. Multiply this one, multiply this one, multiply this one. Whatever the answer comes, add all these. So you get 120. 62. 128. Add all these.
Wait and
Sir, 310.
310. Okay. So now you understood, Arvina, where were you committing mistakes?
Yes, sir.
Okay. This is 120 and this is 62 and this is 128. Okay. This is 0 and 1 carry. Okay. Then 3 and 6, 9, 9 and 2, 11, 1 carry. This is 310. Very good. Proud of you. Done. Rima, Nabila, you have done.
Yes, sir.
yes, sir.
You got the same answer, 310.
Yes,
Yes,
sir.
sir.
Okay. Okay. So let you start, let you do the last one. Calculate the molecular mass of calcium carbonate, CaCO3. Calculate it fast. This is 1. One calcium, 1 carbon, and 3 oxygens. You getting? You getting?
Yes, I'm getting.
Sir, is it 188?
Okay. What's the mass of calcium you have put?
40?
Okay, 1 into 40, because there is one only calcium. What's the mass of carbon that you have put?
12?
Okay, one single carbon atom. What is the mass of one oxygen atom?
16.
Sir, is it 100?
It is 100. Multiply 1 into 40, what you will get, Arvina?
40.
Okay. 1 into 12, what you will get?
12.
And 16 into 3.
48,
48.
When you add all these, you get 100.
100.
Let it be. Okay. So that's all for today. We'll meet you in the next class. Dear students, enjoy the class. Okay.
Okay, sir.
Take care.
Thank
Thank
you,
you,
sir.
sir. Bye.